Right. As I told you, the first topic that we are going to discuss is how your machine is going to be booted. I mean, we are learning completely with reference to Linux. Linux and Ubuntu is what we are using completely, and I told you what Linux is all about. Linux is a free version which is available in the market. Unix is a paid version. When you want to go with Unix, it is paid. When you want to go with Linux, it is free. There are multiple variants of Linux which is available in the market. You can download it online, like Ubuntu, like Debian, like Mint. There are so many operating system variants which are available and supported for Linux to be used. Linux is free. That is the major difference that we have between the Linux and Unix, but otherwise they follow mostly the common guidelines and common features as well. But Linux is free. Remember that you can download and use it. Now we need to understand how typically an operating system can get booted. Booting is all about starting. I want to start my machine. How typically can I start it? That's the most important point that we need to understand. You can start it for the first time, or you can restart it also, right? So the booting can be in two ways. It can be either you start it for the first time in the morning when you are starting the PC for the first time. You are starting it for the first time, that's also booting. When you restart, it is also booting only. We are rebooting, that's all. So we can call it as warm boot or cold boot. I can restart my machine or I can start my machine for the first time. Anything is okay. To perform a cold boot, which means it is hard boot, it is all about you are starting the computer which is turned off. I am going to start a computer which is already turned off. But another side, on the contrary, if you see warm boot, it is nothing but restarting a machine. Remember, there are two types of booting available. One is warm booting, another one is cold booting. Cold booting is all about starting the machine which is already off, on getting the machine restarting is called warm booting. Remember it. Wherever you go, whatever type of booting you do, there are some things which will remain in common, and the booting process is to be understood. That's what I'm trying to convey you today, and I hope you will understand that very clearly. Now what I'm going to do, I am starting the machine for the first time, or I am starting the machine for the second time. I mean, I restart it. So whatever be it, we have two very important tasks to be performed. The first task that is very important to be performed, the first task which is very important to be performed, I repeat, is the BIOS. What is BIOS, sir? It is nothing but the basic input output system. And the second very important task that is being done is post. What is post, sir? It is nothing but the power on self test. We are going to do these two, and these two guys are really very important guys to be called, and the work will be done only when these two guys are all set. There is a process, there is a sequence which you need to follow, and there are 6 steps that experts normally suggest will happen during an operating system getting a loader. Particularly when we go with Linux, we are going to have the same steps, same set of sequences and the stages followed. I am going to explain you that step by step. Please follow. I'll talk about the post a little later in detail, but for now this is sufficient for you to understand. So remember and listen carefully. The first step is all about BIOS. As I told you, it is basic input output system. BIOS does multiple work, and one of the very important works that it does is post. BIOS has got post as part of it. What is post? Post is power on self test. What does it do, sir? Very simple. It will check if things are fine. It will check if hardware is all fine. Whatever ICs you have on the board, whatever components you have on the board, whatever wiring you have on the board, all those are fine to be started. All those fundamentals are okay to be started. It is like the pilot performing the test before he starts the flight. It is like the fundamental test which can let you know if the machine can be started. This will happen in spite of it being a cold boot or warm boot. It can be anything, that's fine. It will go ahead with it. And when you restart, when you start for the first time, the date and time, they have to be definitely restored. So this takes care of it. I'm going to take care of restoring the date and the time. That's how you get the date and time updated even when you log in after 10 days. Even when you log in after 1 month, your date and time gets updated because the post, I mean the BIOS takes care of it. And most important point that we need to understand here is I have a set of software files which are to be run, which will be stored in ROM. ROM is nothing but the read-only memory. That memory cannot be erased. That memory is read-only. You cannot access it. What will be there, sir? Very simple. The content which will be helpful for the operating system to be loaded would be there. It will call corresponding files like you calling the function in the Python or in C programming, and it will have to be called. So who takes care of it? The BIOS helps you in doing that. It will identify what are all the addresses to be visited to call which files which are required for the loading process to be complete. Very simple and very important step this is. And the next very important step is, where do we search the boot file for? Is our boot file available in the hard drive, or is it available in the CD, or do you boot it from the pen drive image? Where do we get it from? You must have installed Ubuntu through multiple options. Somebody would have installed it as a full-time operating system. Somebody would have installed it as an application. So where do we have to boot from? If we have to boot from the hard drive will have to store the file to be called. If you have to boot it from the pen drive, you can do that too. If you have booted from the CD, you can do that too. So the options for the boot order would all be available with this process. We are going to take care of it. And MBR is the next thing which will be called. What is MBR, sir? It is master boot record. So what is BIOS? BIOS has got the post to be invoked. It will check if it is a cold boot or warm boot. It will restore the date, time, etc. It will make sure all the necessary files are loaded with corresponding address being pointed. It also identifies you from where you can boot the machine. Simple. And the first step is done. So the next step is going to be master boot record. What is it, sir? We will see that right now. What is the first step, sir? We completed BIOS. What is the second step, sir? Master boot record. Once the BIOS is all done, I am repeating, once the BIOS is all successful, if it is not successful, you will see a blue screen error, or corresponding operating system will have its own error message, could be in a terminal or could be on a screen which tells you that things are wrong. If BIOS fails, you cannot pass. BIOS fails, you cannot get the system up and running. So you need to understand the point that the BIOS is going to be something like heart of the entire process. It has to be cleared for you to get into the next level. The BIOS will now hand over the control to master boot record. What is master boot record, sir? The name suggested. What is master boot record? The entire this particular package has got where the bootloader is available, what are all the partitions that are to be available, C drive, D drive, partition information, and the most important point is grub. Grub is Grand Unified Bootloader. What do you mean by that, sir? I'll tell you this way. When you are having multiple operating system available with you, now if you see that the word grub is very important. What is it, sir? It is going to tell you how do we select the operating systems for calling. What do you mean by that, sir? Sir, I have a laptop. The laptop has got Windows installed. The laptop has got Ubuntu installed. The laptop has got Sun Solaris installed. While booting the machine, the grub will help you in selecting which operating system you want to go ahead with. That is the main role of grub. When you see a screen, if it asks you for select the operating system for me to run, you can detect it as a grub. That's it. It's very simple. This is the easiest way somebody can help you in understanding grub. So remember, it's going to help you in getting the operating system of your choice loaded. Very simple. Now what is the next thing, sir? The grub, when it is alive, the grub, when it is all done, your corresponding operating system will start getting loaded and you are almost into the process. So what is the next step, sir? The grub will help you to select one of the operating systems from the list, as I told you. If you do not have multiple operating systems, the role of the grub might not be as complex as it does when you have multiple operating systems. Once selected, once the operating system is selected, the control will be transferred to the corresponding kernel. Remember, the term is very important here. Once you select, once you are done with the selection of the operating system, the control has to be given to the corresponding operating system. It's like you are getting into a hospital, you've got multiple departments available, you need to get in and you need to select which department you want to go to. You have got a kidney problem, go to that department. You've got a brain related issue, go to that department. Once you go there and select, the department will take over. That's it. That's the simplest way I can refer you that. So grub will now hand over the control to the kernel of the operating system which you have selected. Now, where is the configuration file available, sir? You can check this as well. I repeat, you can check this as well by going into /boot, which is a file system that I have shown you some time back when I have taught you the process of how do we see the file systems. /boot, inside there will be something called as grub, and inside there will be something called as grub.conf. You can read that file. Cat grub.conf will help you in understanding how exactly it looks like. So we have completed the BIOS, We have completed the MBR, we have completed the grub, and the control is now handed over to kernel. Now what will happen? The file systems will now come into picture. The file system is now going to play a vital role. The first file system that gets mounted is the root file system. Now what will happen? The kernel will start initializing all the necessary stuff. You need a lot of processes for you to run, for you to use the machine. So kernel will start doing that. Where is it available, sir? How can I track? I'll show you that during the demo right now after some time. You can track, you can identify, you can see the init process getting started. The init will be given. Init is nothing but initialize. The init process is the one that is going to go ahead with all the initialization for you to start the work. So it's the first process to get booted. Also remember the daemon is called that. There are daemons. So what is that? It will run automatically without you calling it. There are some programs that will be running in the background without you calling it. So that will also be loaded, and you can set that also. You will learn that at the higher level when you come to the fourth semester, when you study operating system as in how do we create a file which can automatically invoke itself without having the user required to start it. That's called a daemon file. It runs in the background. So what do we do now? The first step is BIOS. It has got post inside. And the second step is MBR. It has called the grub. The grub will hand over the control to kernel, and the kernel will now move the control to init where everything is started. That's all. It's very easy for you to understand, and we have got on its entirety understanding of the Linux booting process. This process would remain the same, the more or less for almost all the operating systems. There could be minor changes here and there, but the entire flow would remain the same. So please understand, booting Linux is very important, and I have explained you that in easier steps. I will share this PPT also at the end of the session so that you can go through it. Is it clear? Now, what do we learn next? We need to learn a little bit more detailed about the post. What is post, sir? I already told you that in the previous discussion, right? Post is nothing but power on self test. Very simple. When you boot your machine, this will happen. When you restart your machine, this will happen. That's what I told you some time back. Now, what is it? Why do we need it, sir? It is the process where you carry out the diagnosis or checking. You can call it the diagnosis or you can call it checking. It checks multiple items, and only if they are found working correctly, they will go on with the further process, which is nothing but loading the operating system. Somebody asked me a question, what will happen when the grub is called? The grub will be helping you to select the OS. Once you select, it will go ahead with the calling things. So all these are a sequence. As I told you that way, here in BIOS, what happens is it will call the post. The post will go ahead and check and diagnose the things which are available. Only if they are found working, it will load the complete operating system. Otherwise, it will halt it. Means it will tell you where the fault is. There are codes available. It will raise you beeps, and it will tell you that there is a mistake. Please look into it. So what are all the things that it checks? It checks for your input output devices. You have connected the mouse, you have connected the monitor, you have connected the keyboards. Does all those things get connected properly to the board? Is the power supply properly given to that? Are they all in proper condition? Then it checks the RAM. RAM is the most important component in the entire process. If RAM gets trouble, the entire things get trouble. So it will check if RAM is properly available, RAM has got no corrupted sectors, is it okay to function? All those diagnoses will happen. And then it will go on with quick check of hard drives. Then all the PC hardware. You got a lot of components in motherboard. That's why it is called motherboard. It gets everything inside. So motherboard will be checked, and motherboard's components will be checked for the power supply, for the connections, for its functioning. All those happen real fast. If it takes a lot of time, you really do not want to go with booting process that enables you to go with post. So it all happens real fast, and that is fully supported by the software, which helps you to understand if all the interfaces, hardware, peripheral connections, all those are fine. So once it is done, we get the next process loaded. But we need to understand what are all the most important principal duties. I've got duties available, but I need to understand what are all the most important primary duties which are available for post. It will check and verify the CPU registers. What do you mean by that, sir? I have a CPU. Say I have Intel Core i7 processor. It itself has got some memory in it. They are fast memory, and they are to be checked, and it checks the CPU registers. You will learn more about it when you come to a course called Embedded Systems. We out and out use the CPU registers there. Then it checks for BIOS locations, BIOS integrity. Whatever content that the BIOS has got, whatever settings the BIOS has been enabled with, will be checked. To check all the peripherals which include DMA. DMA is direct memory access. It will be too high for you to understand if I tell you now, so skip it. Timer. There are timers available on board. Interface controllers. There are controllers which will enable you to interface your HDMI, your cables that enable you to connect your keyboard. All those come under the interface controllers. Check if main memory is okay. Main memory is nothing but your RAM. RAM is like everything there. Without RAM, nothing will work. So I need to check RAM and to identify and organize devices for proper booting. All these are done through post. Post will be the beginning stage of the BIOS. People ask me a question consistently, are BIOS and post two different process? No, BIOS is the process that is at the bigger level. BIOS has got a subset called as post which will start in the beginning of the BIOS. Post is the first step of BIOS. You can take it up that way. So remember it, that's a very important interview question. People may ask you, are post and BIOS two different process? No, BIOS is the mother and post is the child of it, which will be called first. The first child which will be called is the post. Remember it. Now, if everything is okay, the system will boot. If not, we have got a lot of beep signals which are available. If there is one beep, the BIOS ROM itself is corrupted. If there are two beeps, the memory RAM is not at all detected. You could not have plugged it, or there could be a slippage in the fitting. Three beeps, the motherboard itself has got a power supply failure or some other connection issues. Four beeps, it is going to tell you that there is a RAM failure. Five beeps, CMOS battery failure. Somebody asked me this question. How will we detect if CMOS is going to go off? There will be an alert well in advance to you saying that the CMOS is going to die. So the battery will be intimated, the battery's life will be intimated that it is weaker through this 5 beeps. And 6 beeps will help you in understanding that video card connection failures. And 7 beeps will tell you that there is a huge problem that comes with the CPU itself. So remember, there are many other signals available as well, but I have taken the best of the instances for this and I am explaining here. So post will help you in understanding if things are all right. Do we do the right things? Is all things are right? That is what going to be tested by post. Please understand, BIOS and post are like very important process without which things won't work fine. So please remember, without BIOS, without post, it won't work. Any question till now? Right. We are getting to the next topic where you can quickly understand what is system call. System calls is a very important area of working, particularly when it comes to Linux or any operating system for that matter. System calls is a very important topic. What is it, sir? System call is nothing but a function. You can call it a function. Sir, what do you mean by that, sir? You know printf, right? Printf, scanf, all these functions you know, right? System call is like that as well. System call is a function which you can call anytime. But why do we then call it system call? Why cannot we call it a function right away? You can ask me a question, right? Sir, you are saying it as a function. Then why cannot we call it a function? Why do we specifically call it a system call? There is a reason. These functions will be running only when you call it from that operating system. For example, the system calls which are available, which are created for Linux will run only in Linux. It won't run in Windows. The system calls which are available for Windows will not run in Linux. So they are very specific to the system that you are using, and that's why we call it system call. The reason is very simple. They cannot be invoked from any other operating system. Sir, I have a Windows system call. Can I run it from Linux? No, you cannot run it. Or I can tell you this way, I have a Windows function which is made available. Can I run it in Linux? No, you cannot do that, because the complete structure of the operating system from software and the hardware perspective is all different. The way these guys write operating system is different. The way those guys write operating system is different. So they cannot match. It is like you studying electrical engineering and someone is studying mechanical engineering. Can you go and sit in different classes? Can you swap the classes? No, you cannot do that, because both the domains are entirely different. That's it. So I've got two operating systems. Both have got a lot of inbuilt functionalities available. You can call those inbuilt functionalities, but you can call that only from that particular operating system. You can call your parents only from your house. You can gain access from them only from your house. When you go to different house and govern, they won't respond. The parents of other people won't respond to you. That's it. So the system calls are very specific to that operating system, and you cannot access them outside that particular operating system. They are an interface actually. They are fundamentally providing you the resources to be accessed in a very smooth way. Operating system on the whole is a resource manager. They help you to manage, to access the resources. So what do we do here? Very simple. these system calls are going to help us out in accessing the available resources in a neat way. They are functions which we are going to call and we are going to use them. That's it. Very simple. How do we do, sir? We are going to use some very simple functions available. I'll show you one typical example that I have tried out and it will help you in understanding how system calls work. There are numerous system calls available. If I start explaining that now, it will not be proper for you. So it will be dealt separately in the third semester or the fourth semester when you go to operating systems paper properly. But now understand that they can help you in acquiring the input. They can help you in writing the output to the screen. They can help you in creating files, writing the files, deleting the files. All these operations can be done with the system call. Excuse me. The system calls are kind of the functions, as I told you, will help you in doing everything right. So what are we going to do, sir? Very simple. I'm going to write a very simple code right now for you, and that code will help you in understanding how exactly system calls are to be handled. I'm going to write a very simple code, and you need not memorize this code. Remember, sir, coding and all we do not know, sir. I know that you may not know right now, but you need not memorize. Please don't memorize. You can learn all this, and all these are available in man page also. You can take help from that, and it's pretty easy. Before I go into the system calls part, I wanted to show you the first process that is booted in the system, which is called init. I told you that in the Linux we have something called as init, so we are going to see that first. Now you can see that I'm going to the mount point, cd space backslash. Now where am I in? I am in the mount point, and inside that I have all the file systems available, and you have got the file system called as boot available here, and we need to track what is the first process. So the process can be tracked simply through proc. Proc is a file system which tracks all the processes. I am into the proc right now and I am doing an ls. There you can see something like 1. 1 is here. So this is called, this is the first process that is loaded in the machine. See the time 8:52. It is the first process, and this 1 is nothing but the init. This 1 is the first process that gets loaded, and this is the parent process or grandparent process or superior process that you can call for all other processes that are available. Is it clear? Remember it. Where did I go? I was like this. This was the plain screen that I had. I went to the mount point. I then did an ls. I then went to the folder called as, or the file system called as proc, and inside that I had multiple processes available, multiple contents available. Don't worry about it. It is too high for you right now. ls-lrt if I put, I have 1 here, and 1 is nothing but the process called as init, which will help me in loading the operating system. That's all. So I told you this the theoretical part without showing the demo. Now it is time for you to see the demo, so I have shown you the demo. Now, what am I going to do, sir? As I told you, I am going to use a system call. What is a system call, sir? It is a function. It is a simple function. So which system call are you going to use, sir? You can see that here. Let me clear the screen. Get 1.c. I have written a code already. So let's take this. This is too high for you right now. Okay. This is the file that I have used right now. Now here what I am doing, I write a simple C program by invoking a system call called as create. This create, see the spelling carefully. This create is the system call that is going to help me in creating files. That's it. So what do? I included stdio.h. This is proper normal C program. I included standard input output libraries. And inside that I have got fd1 and fd2 as 2 integers. What are they, sir? They will collect the return. When these files are created, it will give a number as the return for a reference acknowledgement. That return number will be stored here. When I create the second file, that return number will be stored here, and we call it fd1 and fd2. What is fd, sir? That is file descriptor. It describes the file creator, that connects the file creator. I repeat, I have a header file which is normal stdio.h, and I have got 2 integers already available here. First integer is called fd1, and that collects the return value the moment text1.txt is created. I collect the return value the moment text2.txt is created, and they are stored in fd1 and fd2. Sir, what if they are not stored, sir? Nothing will happen. This is for my reference. I am collecting it. That's all. Now we are going to create 2 files, and it is done with the system call called as create. Please see the spelling. It is create, and this is called a system call. This is a feature that is available within Linux, which you can call towards creating a file Otherwise, you will have to code it with a complex procedure, or you may have to manually create a file like what you have done with cat command. Now it is very easy for me to create. Let us see if there are already files available in the same name here. Let me remove all those rm.txt1.txt, txt2.txt. I have removed them. Now what I am going to do is I am going to compile this file. cat2.c is available, and you may ask me a question, what is this 777? I'll tell you that a little later. Hold on. Rest things I explained you very clearly. So please understand, I am calling a system call called create, and it needs the file name to be created along with the permissions. 777 is nothing but 7 is for read, write and execute. Sir, what do you mean, sir? I'll show you this way. Please remember, read, write and execute. Read is assigned with 4, write is assigned with 2, execute is assigned with 1. So when I create a file, I need to tell what kind of permissions it has for the file. What is 4 plus 2 plus 1? 7. When I give 7, it means that we have got read, write, execute permissions all available. If you want only read, write permissions, it is 4 plus 2. So 4 plus 2 is 6. I will make it 666. Sir, why do you have to give it thrice, sir? I'll tell you that. Linux has got 3 users. What do you mean by that, sir? Very simple. You see it here. Linux has got 3 users available. So we have to specify everything clearly. This is the owner. The first one is the owner. The second one is the group I belong to. Third one is others. I created the file. I belong to the group called as professors, and this is for others. So whenever I create a file, I need to specify the permissions that are to be given for the owner, that is myself, the group that I belong to, and for others. When you give 777, it is read, write, execute permissions for everybody. Now what do I do, sir? Very simple. We are going to compile the file gcc-o 1.2.c. 1 is the name of the executable file. Don't worry. I can call it Sachin Ganguly, anything. Now that's a warning message. You need not bother about it much. I'm clearing the screen. Now we need to see if 1 is available. You can see that 1 is available here. So I'm going to run it /1. Now this will create 2 files, that is printed. We need to see if the files are created. You can see that there is no text1.txt, no text2.txt available here. We will have to check right now. Text1.txt is created, text2.txt is created. See that we have got read, write, execute permission. Read, write is not given. Why? I do not know. Read, execute is there. Oh, by default it is not given. Read, execute is there. So this is what is called as permissions. So don't worry about it much now. We are able to create 2 files, and the 2 files are created using the create system call. The create system call can be invoked, and likewise there are multiple system calls available, and they are nothing but the functions which are available within the operating system for you to invoke them. Whenever you want, you can use them. That's the point. I hope I clarified it clearly. So ABC is here right today. So we need to try all these out in the lab, which I'll tell you when I come to the lab session also in parallel. Also, we've got some commands to be discussed and then to be frozen at the end of the lab session. At the end of my discussion in the lab session, you can try them out.